Math Blast 7, determining the unknown. Fill in the missing factor. 3 times what equals 15? I'm going to use my skip counting by threes to help me figure this out. 3, 6, 9, 12, 15. I see that when I have 5 groups of 3, I get to 15. So I know that 5 times 3 is 15, and 3 times 5 is 15. The commutative property helps me to figure that one out. 18 equals 3 times what? Again, let's use our skip counting by threes here. 3, 6, 9, 12, 15, and 18. I know that 6 groups of 3 is 18. So 6 times 3 is 18. Or the commutative property says 3 times 6 is also 18. 30 divided by 5 equals what? In this case, 30 is my total. And I'm going to divide by 5. So I'm going to divide into 5 groups here. I want to take my total 30 and equally share them among these 5 groups and see how many are in each group. So there's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Each group has 6. So 30 divided by 5 is equal to 6. 6 equals something divided by 2. I see here that it is the total that I'm missing. So I need to figure out what are my total items. And then I'm going to divide by 2. In this case, I'm going to call the 2 my groups. And the 6 is going to be the number in the groups. So with that in mind, I'm going to create 2 groups, and I'm going to put 6 in each group. And then I can see what my total would have been, 12. So when I have 12 and I divide those into 2 groups, I get 6. Therefore, the missing number here is 12. Patterns. What rule is the function machine using? When we're dealing with the function machine here, what we're trying to do is figure out what is happening to each input number to get each output number. So to go from 9 to 3, I know I can subtract 6, or I can divide by 3. Now, what's important here is that for each row of the function table, the same thing needs to be happening in order for it to be considered the rule. So, to get from 12, can I subtract 6 and get 4? No way. Therefore, we're going to get rid of that one. Let's test the division by 3. Can I take 12 and divide by 3 to get 4? Yes. For 15, to get to 5, can I divide by 3? Yes. So as you notice, all the way through the table, we are able to take our input numbers and divide by 3 to get the output. Therefore, the rule is input divided by 3 equals the output. Subtraction. Subtract 76 minus 44. In this case, I'm going to start with my ones, and I have 6 I need to take 4 away from. That would be 2. I'm now going to work with my tens digits. I have 7 minus 4, that would be 3. 3 tens and 2 ones. So 32 is the difference. The difference is the answer to a subtraction problem. 127 minus 38. In this case, I could set this problem up to where I have 127 and in a vertical form, write 38 right under the correct place values. I have 8 ones and 3 tens, and solve it using the standard algorithm as we did here. Or I could use another method, which I'm going to demonstrate here, known as the arrow method. I will start with 127, and I will take away pieces of the 38 until I have taken away all 38. So I'm going to start by taking away 20. And I could start with any that I want to, but I like the idea of taking away 20 here. That leaves me with 107. I'm then going to take away 10. I can go back 10 and be at 97. Notice I've taken away 30 total. I need to take away 38. So let's take away 7 to get us to that 90 mark. And I know I need to take away one more, and that would put me at 89. So the difference for 127 and 38 is 89. Fractions of a region. The picture below is the whole. What fraction of the whole is shaded? When we're talking about a fraction, we're looking at a part over the whole. A part of the whole. And in this case, the part that we're focusing on is the shaded. So I need to see how many are shaded. 1, 2, 3, 4. 4 of the pieces or parts here are shaded out of 6 pieces or parts in the whole. So 4/6 of the whole is shaded. Elapsed time. Write the time shown on each clock. For the first clock, I notice that my hour hand, the short hand, is at 9. And I notice that the minute hand is at the top of the clock, at the 12, where we start a new hour at 0 minutes, so it is 9 o'clock. On the second clock, the end clock here, I notice that my hour hand is at 10. And I notice that my minute hand is at the 6. Now, I remember that starting at the top of the clock starts the hour, 10 o'clock, and going around to every number on the clock is 5 additional minutes. So let's count by 5s. 5, 10, 15, 20, 25, 30. 30 minutes of the hour has passed. So it is 10:30. How much time has passed from start to end? So we're now trying to figure out, to get from 9 o'clock to 10:30, how much time has passed. We know to get from 9 o'clock to 10 o'clock, 1 hour passes. And then to go from the 10 o'clock to 10:30, 30 more minutes has passed. So 1 hour and 30 minutes has passed.